Hi everyone, this is your lesson 3 video on linearizations and linear approximations. I'm on page 13 of your packet. If you could make sure you're there, that would be great. We have one learning objective for today, and it's approximate a value on a curve using the equation of a tangent line. So we have talked lots and lots and lots about finding the equation of a tangent line. Now we're going to talk about what was the point of doing all of that, right? What is the point of finding all these derivatives and evaluating them and doing all that kind of stuff and writing these equations of tangent lines? The point of it is that we're going to use it to approximate values of functions. So really quick, we're going to talk about just quick reminder of how to evaluate. If we've got f of x equals x squared and we want to find f of 2, we're literally just going to plug in 2. So we get 2 squared, which is 4. That's a nice, easy number for us to evaluate. Now, same thing goes for if f of x is x squared and we want to evaluate f of 2.1. So f of 2.1 means 2.1 squared. This is a little bit harder to evaluate without a calculator, but still not that big of a deal, right? We can do 2.1 times 2.1. 1 times 1 is 1, 1 times 2 is 2. We've got a 0. 2 times 1 is 2, and 2 times 2 is 4. So if we add, we get 4, 4, 1. We've got two numbers that are after a decimal point when we're multiplying. That means we're going to have two decimals, 2 points after our decimal for our answer, which means that f of 2.1 is 4.41. So, okay, cool, we were able to evaluate it by hand, fine, whatever, but we're going to talk about how to just approximate this using the tangent line instead. So we're going to talk about linearizations and linear approximations. Since a tangent line stays very close to the graph of a function when it is near the value at which it is tangent, we can use tangent lines to estimate function values. This process is called creating a linearization, or we can call it using a linear approximation. It's really no different than anything we've done so far. We're just adding one more step. So just a really quick visual representation. We've got this parabola x squared. That's the red parabola on our screen. And then we've got this blue tangent line that's drawn in at x equals 2. You'll notice that everything here is so very close that you can't even distinguish between the blue and the red right there, right? When we're very close to x equals 2, this tangent line is so close to the parabola. And so that's why we're able to use it for approximating something around 2. I wouldn't use x equals 2, the tangent line at x equals 2, to approximate something like -1, because that's so far away, right? -1 is all the way over here on my graph. That's not anywhere near where my tangent line is. But anything that's kind of in that pink circled area there, we would be able to use the tangent line at x equals 2 to approximate the function value. So let's talk about how to actually do this. X squared is our function. We want to write the equation of the line tangent to f of x at x equals 2. Well, we know in order to write the equation of a tangent line, we need two things. First, we need a point, and our x value is 2, so we know 2 squared is 4. So the point we're going to use is 2, 4. The second thing that we know we need is we need the slope. Remember, slope of a tangent line means that we need a derivative. So we're going to need to find f prime of x. Since f of x is x squared, we can just use regular old power rule. So we're going to drop the 2 and subtract 1 from the exponents. And so f prime of 2 is just going to be 2 times 2, which is 4. And so the equation of our tangent line that's already drawn on our graph for us is y minus 4 equals 4 times x minus 2. That's where we stopped in Unit 2, right? Now, what we're going to do is we're going to use this tangent line to approximate the value of f of 2.1. So in order to do this, we're going to create our linearization. And what we do then is we take whatever this y value is, and we're going to move it over to the other side of our equation. And we're also going to swap out the y for an L of x. So we're going to say L of x is equal to 4 plus 4 times x minus 2. This is the same equation that I had. I just moved things around a little bit, right? Moved the 4 over, changed the y to an L of x. I like to use L since it's a linearization. Now what we're going to do is we need to approximate f of 2.1. So we're going to say f of 2.1 is approximately equal to L of 2.1. It's going to be roughly close to whatever value is on this tangent line. So on the tangent line, we're going to do 4 plus 4, 2.1 minus 2, and we're just going to simplify this. So we get 4 plus 4 times 0.1. We know that 0.1 times 4 is actually just 0.4, and so we get 4.4. Now remember what we're doing here, what we just calculated is L of 2.1. What we were asked to do is approximate the value of f of 2.1, and we know that they're close to each other. So we're going to say f of 2.1 is approximately equal to 4.4. And that's our answer. So again, all we're doing is the same thing we did in Unit 2, writing the equation of the tangent line, but now we're just going one step further and evaluating it at a specific point. All of these questions are going to be no calculator, so you're going to need to work a little bit with your arithmetic. If we need to work on that, just make sure you ask some questions about it. If you have any questions about this video, make sure you wrote them down, and I will see you all back in class for some practice real soon. Thanks for watching.